Now my dear friends, today we are start the P block elements and general principle and process of isolation of elements. My dear friends, this is the unit 8 and this chapter is well known. This chapter is a 12th standard chapter. My dear friends, lot of questions are asked in this chapter. Process of isolation of elements means another name of this chapter is metallurgy, and different type of process are used in this extraction of metals. So my dear students, name of the process asked through the questions in your NEET exam. Now my dear students, as well as P block elements 15, 16, 17 and 18, these groups P block elements are in standard 12th. So some questions are also asked from P block elements. Now my dear students, we can discuss those questions as well as theory, concept and tricks. Now we can my dear students, we can go to question number 1. That is, which one is a malachite from the following? My dear students, this question is asked in NEET 2019. Here malachite is a ore, and my dear students, when here you can see the name of the ore. What is the name of the ore? So what is the concept? Concept of this question, you must be learn the name of the ore, name of the ores of different metals, my dear students. When you can get the metals, when metals present in on the earth crust, and you can get the different metals from the earth crust, then different processes are used. When these metals are present on earth crust, then these are called ores. So name of the ores of different metals you must be learned. For this, here we can see here malachite. My dear students, malachite is the ore of copper, and formula is, my dear student, that is formula is CO3 and CuHO twice. My dear student, this is the formula CO3 CuHO twice. This malachite ore is also called basic copper carbonate. It is also called basic copper carbonate. So my dear student, here you can see here basic word is a test for a reference for the CuHO twice. So my dear student, it is called basic copper carbonate, and here this is the malachite. Second, another name of ore, that is called azurite. Azurite is the, my dear student, it is the ore of copper. Malachite is the ore of copper. So malachite, azurite is the ore of copper, as well as malachite is the ore of copper. So my dear students, what is the molecular formula of this azurite? When you can 2 mole of copper carbonate and 2 mole of this copper hydroxides are take, then this is the name of the azurite. CO3 and CuOH twice. When you can see here 2 moles of copper carbonate is present, then my dear student, it is called azurite, and here it is called malachite. Now we can learn the different type of ores. For example, CuFeS2, here you can see here in this question, CuFeS2 is called, my dear students, copper pyrite. Copper pyrite, or it is also called iron pyrite. So first you can here write iron pyrite, because my dear students, here we can see the iron elements in this ore, so it is also called iron pyrite. Iron pyrite and formula is CuFeS2. In this way, my dear students, you can learn the ore, name of the ore. When you can see here fourth number ore, that is iron Fe3O4. Fe3O4, it is given in this question. It is called, my dear students, it is called magnetite. Here it is called magnetite. When you can see the name of Fe2O3, it is also a iron oxide ore or oxide ore of iron. It is called, my dear students, hematite. So you can see here all the name of the ore: number 1, number 2, number 3. This is the number 3, and this is number 4, and my dear students, it is the number 5. So here you can see the name of the ore of different metals. Now here NEET 2019, he asked what is the chemical formula of malachite. So you can go the question number 1, answer is A. And you can learn this name of the ore and molecular formula of the ore, my dear students. So I can give you this concept with theory. And small technique I also given to you. Now my dear students, we can see here question number 2, identify the incorrect statement. Here my dear students, we can identify the incorrect statement. Here A is that the scientific and technological process used for isolation of the metal from its ore is known as metallurgy. So what is the metallurgy, my dear students? Metallurgy is the isolation of metal from the different process, and isolation of metal from the ore and used for different process, it's called metallurgy. And this is the correct statement. So you cannot choose this statement, because my dear students, here question asks that you choose incorrect statement. So my dear students, when we go to question number option B, minerals are naturally occurring chemical substances in the earth crust. Here you can see here, yes, minerals are natural occurring chemical substances present in the earth crust. It is the answer correct. Now we can see here, ores are minerals that may contain a metal. Yes, when metal is present on earth crust, then it is called ores. And ores are all ores are minerals, but all minerals are not ores. You can also say here, all ores are minerals, but all minerals are not ores. So here my dear students, you can see this concept. Now we can see this is also a correct statement. Now we can see ores are minerals that may contain a metal. Yes. Number D, option is the D. Gangue is an ore contaminated with undesired material. My dear students, gangue is not an ore. What is a gangue? Here you can see gangue. Gangue is a physically associated impurities. Gangue is a physically associated impurities is called gangue. So my dear friends, here it is called gangue. And what is a gangue? Gangue is a physically associated impurities. So this is incorrect statement. So you can write here incorrect statement, and this question is asked in NEET 2019. Question number 2, answer is D. Now my dear students, we can go to the question number 3. Metals are usually not found as nitrates in their ores. Out of the following 1 and 2 reasons, which is or true for the above observation? Here my dear students, number 1, metal nitrate are highly unstable my dear students, when you can see the NaNO3, for example. This NaNO3, my dear students, sodium nitrate, it is a highly thermal stable because at high temperature it decomposes to NaNO2 plus half O2. So my dear students, you can see here, sodium is a metal nitrates are highly unstable. It's a wrong statement because you can see here sodium nitrate is stable when it is heated at high temperature, then it is converted to sodium nitrite and half O2 at high temperature. It is not decomposed at room temperature, so it is not a correct statement. Now we can go to second statement, my dear students. Metal nitrates are highly soluble in water. This NaNO3, my dear student, it is a ionic compound. So when this NaNO3, this is a ionic compound and it is a metal nitrate. When this is dissolved in water, my dear students, dielectric constant of water decompose this positive and negative ions, and you can get this sodium ions present in water as well as this is called nitrate ions, which is also present in water. So my dear students, you can see here the sodium nitrate are highly soluble in water. It's a correct statement. So you can go to A option because in A option you can see first is false. Highly unstable, this point is false because metal nitrate are stable. And what second is true? Yes, because metal nitrates are soluble in water. So my dear students, you can go to this option number A option and question number third. Now we can go to question number fourth, my dear students. Question number fourth. Here you can see which one of the following is a mineral of iron. Here my dear students, malachite, you can get the malachite from copper ore. So it's a mineral of copper. Cassiterite is a mineral of tin. And this pyrolusite, it's a mineral of potassium. So my dear students, potassium and aluminum is present. So my dear students, you can go the answer D because magnetite is a mineral of iron. And what is the formula of this magnetite? My dear students, this magnetite is a Fe3O4. I give you this trick to learn this magnetite because you always not remember the formula of the magnetite and hematite, and formula of magnetite is, because both are a oxide ore of iron, so formula of magnetite is Fe3O4, while formula of this hematite is Fe2O3. So my dear students, here you can see in magnetite Fe3O4 means more iron atom is present in magnetite, while in hematite less iron atoms are present in hematite. So my dear students, you can see here when more number of iron atoms are present or iron atoms are present in this compound, it is attracts towards the magnetic field. When you can apply the magnetic field, it is attracts towards the magnetic field because iron atom is more. When it attracts towards the magnetic field, so it is called magnetite. So this ore is called magnetite. In this way, you can learn the name of the ore and formula. And hematite, when number of iron is come, that is Fe2O3, then Fe3O4 you can get. So my dear students, I hope you can learn this formula as well as name of the ore. Now we can go to the question number 5th. This question is also asked in 1999 NEET exam. Here my dear students, cassiterite is an ore of, that is the ore of tin. This is a ore of tin. Cassiterite is the ore of tin. So you must be, I advise to you, you must be learn the name of the ore with molecular formulas, and I am giving you this cassiterite ore, name of the cassiterite ore, as well as hematite, magnetite, and some important ore I am also giving in this topic or in this lecture. Now my dear students, when we go to the sixth question, that is the question number 6, in which of the following compounds nitrogen exhibits highest oxidation state. My dear students, here we can start the P block elements here, questions of P block elements. So in P block elements, this question is asked in NEET 2012. So you can, first of all, you can determine the oxidation state. Here A option, we can determine the oxidation state of nitrogen, and that is 2x in this way. 2x, x is the oxidation state of nitrogen. This is the minus, this plus 4, because oxidation state of hydrogen is 1, that equal to 0. So you can get that 2x, that equal to minus 4, then 2x is equal to minus 4 by 2, that equal to minus 2. So my dear students, here you can get the minus 2 oxidation state. Now we can get the, determine the oxidation state of in ammonia, ammonia in nitrogen, nitrogen in ammonia. So here x plus 3, that equal to 0. So x is equal to minus 3. So you can determine the oxidation state of nitrogen, that is minus 3. Now my dear students, when we calculate the oxidation state of nitrogen, the N3H, it is called hydrazoic acid. N3H, this compound is called, my dear students, hydrazoic acid, and we can determine this oxidation state of nitrogen, that is 3x plus 1, that equal to 0, then 3x is equal to minus 1, then x is equal to minus 1 by 3. Here my dear students, when we determine the oxidation state of nitrogen in NH2H and H2OH, here you can see x for nitrogen plus 2, here for hydrogen minus 2 for this oxygen, and plus 1 for this hydrogen, and that equal to 0. In this way you can determine x plus 2 plus 1 plus 3 minus 2 is equal to 0. So my dear students, x is equal to minus 3 plus 2. So you can get the minus 1 oxidation state of nitrogen NH2H molecule. So here you can get the oxidation states of nitrogen. Now you can see what is the question. Question is that, my dear students, in which of the following compounds nitrogen exhibit highest oxidation state? Here my dear students, nitrogen get the negative oxidation state, and in negative you can see the oxidation state of N3OH. N3H is the minus 1 by 3. So my dear students, it is a highest oxidation state. So you can get the C option, C answer, question number 6. So my dear students, when you see the question number 7, nitrogen forms N2 what phosphorus does not form P2. However, it converts P4, reason is. Here you can see the concept for this question. You can see the nitrogen is always present in N triple bond N, but here question is that phosphorus is not present P triple bond P. Here it is not present P triple bond P. while this phosphorus present as a P4. What is the reason? Question asked, what is the reason? A option, here triple bond present between phosphorus atom. It is wrong answer because triple bond is not present. So this is the wrong answer. Now we can see P-pi bonding is weak. Yes, my dear students. When this phosphorus molecule form, because it's a size of the phosphorus is bigger. Size of the phosphorus is large. So in the large size of phosphorus, when triple bond is present, then this bond length is higher, and due to the bond length is higher, so these bonds are bigger, easily broken down. So my dear students, you cannot get P2 molecules. You cannot get P2 molecules. So you give the answer B, P-pi bonding is weak. When this bonding is strong, my dear students, then this molecule is formed. So it means this P-pi bonding is strong in N2 molecule. When, my dear students, you can see here N2, here P-pi bonding is very strong. Multiple bonds form easily? Not. The answer is B. Here P-pi bonding is very strong in N2. So my dear students, this is a concept. Here phosphorus atom has a very big size. So bond length is triple bonds and bond length is higher or larger. So these bonds are bigger, and due to these bigger bonds, these bonds are easily broken. So my dear students, P2 molecule is not formed. Now we can go to the question number 8 and see the concept, which concept is applied. Here my dear students, which of the following oxide is most acidic? And you know very well concept. What is the concept, my dear students? Concept is that non-metal oxides are acidic nature. Non-metal oxides are acidic nature. And number second concept, my dear students, metal oxides are here basic in nature. And my dear students, when we can see the third point, it is called amphoteric metal. So amphoteric or metalloids, you can also say here metalloids. Non-metal means here nitrogen, my dear students. Metal, you can see here metal means bismuth. And metalloids. Metalloids oxides are amphoteric in nature. Metalloids oxides are amphoteric in nature. So my dear students, here what are the metalloids? Arsenic and antimony. Both are metalloids. Here nitrogen and phosphorus, both are non-metals. But you can see the non-metallic character percent nitrogen is higher than phosphorus. So my dear students, here most acidic question is that which of the following oxide is most acidic? That is answer is N2O5. Our answer is N2O5. Here my dear students, when we see the metalloid oxides, arsenic and antimony, Both metalloid oxides are amphoteric in nature. So this is the concept, my dear students. When we see the p block elements for 15th group here, nitrogen, phosphorus, arsenic, antimony and bismuth. My dear students, when we move to top to bottom in a group, we can get in this group, metallic character increases. Metallic character increases. So my dear students, when you can see the nitrogen is a non-metal, while you can see this bismuth is a metal. And this arsenic and antimony is a metalloids. Here phosphorus is also a non-metal, but it's a solid and it's a gas. So in a gas, non-metallic character is greater. So N2O5 is your answer. My dear students, question number 8, answer is C. And you can see the concept. Now we can go to the question number 9. Which of the following has the highest dipole moment? My dear students, you can know that dipole moment depend on the magnitude of the charge. So this is the concept. Here we can see the concept. When charge of an element which is highly electronegative and a highly electropositive element or hydrogen, when charge of an element that is electronegative and hydrogen is maximum indifference, then we can see the magnetic moment or dipole moment is higher. Here my dear students, when here these elements are present, 15th group elements, here nitrogen, phosphorus, arsenic and antimony. Here these are 4 metals or elements are given in your option. Now we can see the top to bottom. This is the 15th group elements. When we move top to bottom or 16 or 17 or 18, it is applicable to all groups. Then electronegativity decreases. When electronegativity decreases, it means dipole moment also decreases. So my dear students, here nitrogen is highly electronegative, then phosphorus, arsenic, antimony. So dipole moment is highest in ammonia molecule. And this is the answer. Question number 9, you get answer C, my dear students. And this question is also asked in 1997 NEET exam. Now we can see the next question, that is question number 10. Here my dear student, the basic character of hydrides of the 5th group elements decreases in the order. But the concept of this question. My dear students, basicity of hydrides. Basicity of hydrides is proportional to lone pair of electrons present on element. Lone pair of electron present on element. So my dear students, here you can see the basicity of hydride is proportional to lone pair of electrons present on element. Here my dear students, when size increases, atomic size increases, then basicity decreases. So you can see here, basicity is inversely proportional to atomic size of an element or of an atom. So my dear students, here atomic size is increases, so here basicity decreases. So you can go to the option A. Option A is the correct answer, and this question is also come in your NEET exam 1996. Question number 10 this is. Now my dear students, we can go to the question number 11. Here my dear students, question number 11, this is the same question, concept is same. Basic order or acidic order. Here you can see the lowest acidic. Lowest acidic means, my dear friends, lowest acidic compound are the more basic. Those compounds are the lowest acidic means those compounds are the more basic. So my dear students, here more basic compounds means you can see here metalloids are the more basic, and in which metalloids oxides are the more basic. So my dear students, here more basic than non-metal oxides. Here you can see here, this is the metalloid oxides. These are the more basic than non-metal oxides. Here this is non-metal and here this is also non-metal. Now we can see when metalloids, here As4O6 and As4O10. What is the difference between these two compounds, As4O6 and As4O10? Here my dear students, here oxidation number of this arsenic is +3 and here oxidation number is +4, because here you can calculate 4x minus 12 is equal to 0, 4x is equal to 12 and x is equal to 12 by 4. That's why you can get the +3 oxidation state. Here you can calculate this oxidation state in As4O10 in this way, 4x minus 20 is equal to 0. Here oxidation state of As4O10, that is the +5. Here oxidation state is +3 and here oxidation state is +5. Now 4x minus 20 is equal to 0. So 4x is equal to 20 and x is equal to 20 by 4. And my dear students, this 20 by 4 means +5. You can see here oxidation state of arsenic is +5. And you can see here oxidation state of this arsenic is +3. So my dear students, lower oxidation state, same metalloid oxides or metal are same, but oxidation state here is higher and here is lower. Higher oxidation state, oxides are more acidic, so it is a less basic, and here lowest acidic oxide is more basic. So my dear students, you can go the option A, that is As4O6. This is the lowest acidic means more basic. Lowest acidic means more basic. So my dear students, this As4O6 is a more basic than As4O10. These are the concept to determine the acidity of the oxides or acidic nature of the oxides. Now my dear students, we can go to the question number 12. Here we can see the which of the following fluorides does not exist. My dear students, answer is A. Question asked in 1993. Here, why we can get this answer? NF5. Reason is simple, my dear students. Nitrogen, D orbital is absent in nitrogen. Nitrogen d orbital is absent in nitrogen. D orbital absent in nitrogen. My dear students, here d orbital is absent in nitrogen, and here you can see here this NF5, AS5, PF5, SB5 is present. It means this, when NF5 is present, d orbital is must be there, and d orbital is absent in nitrogen. Atomic number of nitrogen is 7, 1s2, 2s2 and 2p. This is electronic configuration of nitrogen. Here this is the K shell, and this is, my dear students, L shell is present. Here, my dear students, in K shell only one s orbital is present, and here L shell you can see this 2s and 2p orbitals are present. Here, my dear students, you cannot get the d orbitals. So d orbital is absent in nitrogen. So these electrons are not go to the d orbitals because d orbital is not there. But in case of this phosphorus, atomic number of phosphorus is, my dear students, that is 15. When you can get the electronic configuration 1s2, 2s2, 2p6, here 3s2 and 3p3. Here, my dear students, K shell is present. Here you can see L shell is present, and here you can see M shell is present. K shell only one orbital is present, 1s. Here L shell you can get the two orbital 2s and 2p. And here M shell you can get the three orbital 3s, 3p and 3d. My dear students, you can see here in third shell, third orbital is present, but this third orbital is empty, so you can not see in the electronic configuration. But this orbital is present. No electron is in this orbital, so you cannot written here. When this phosphorus is in excited state, or you can give some amount of energy, so, my dear student, this paired electrons are go to the d orbitals. When these paired electrons are go to the d orbitals, my dear students, then you can see here 3s, only one electron is present, 3p, 3 electrons are present, and when this is a 3s, 3p, and you can see here 3d, one electron is coming from the s orbital. In this way you can see here 5 unpaired electrons are present in this phosphorus in excited state, or if you can give the some energy as a form of heat or as a form of ultraviolet light. Here, my dear students, here 5 unpaired electrons when present. Here this phosphorus atom, 5 unpaired electrons are present. These 5 fluoride ions are come with phosphorus, and when these fluoride ions, fluorine atom see this unpaired electron here, then he want the sharing, because one unpaired electron present in fluorine. So, my dear students, you can see here 5 fluorine atoms sharing the electrons and form the covalent bond. So, my dear students, in this type, you can see here phosphorus, and below the phosphorus arsenic and antimony, in which d orbital is also present, 5 are formed AS5, SB, F5 type compounds. But, my dear students, this nitrogen cannot form this NF5 type compounds, because here in nitrogen only L shell or L orbital is present. My dear students, the K element is called shell, or you can also call it as a subshell or subshell. So, my dear students, this is the concept, and due to this concept you can solve the problem and you can get the answer A. 12th, answer A. And this question is asked in 1993 NEET exam. Now, my dear students, we can go to the question number 13. Which one has the lowest boiling point? Here, my dear students, we can see that boiling point is lowest when nitrogen, phosphorus, arsenic, antimony and bismuth. Here, my dear students, when this move the top to bottom in a group, boiling point is increases for hydrides. So, you can see here boiling point is increases from top to bottom. But my dear students, when this hydride NH3 is formed, here NH3 is exception is there, exception due to presence of hydrogen bonding. My dear students, this ammonia get higher boiling point. Boiling point of ammonia is higher than this antimony and bismuth. So, my dear students, this is the increasing the boiling point, but except this nitrogen. So, you can get this PS3, here ASS3 is formed, arsine. Here for antimony you can get as BS3 styrene. Here you can get BIS3, it is called bismuthine. Here, my dear students, so lowest boiling point is present in phosphine, PS3. So, you can go the answer PS3, and this PS3 is called phosphine. Now, my dear students, we can go to the question number 14. Here you can see that number of electrons shared in the formation of nitrogen molecules. Here you can write the structure of nitrogen, and you can easily see the structure of nitrogen, that is N triple bond N. Here in one bond 2 electrons are sharing, of 2 electrons are sharing of 2 electrons are occur. 2 electrons sharing are occur. So, my dear students, in one bond 2 electrons sharing are occur. Here you can see the 3 triple bond is present. My dear students, when triple bond is present 1, 2, 3, then 3 multiplied by 2, you can get the 6 electrons. So, number of electrons shared in the formation of nitrogen molecule, that equal to, my dear students, 6. So, you can go the question number 14, you can go the answer A. Now, we can discuss the next question, and that is next question is the question number 15. Here nitrogen is relatively inactive element because, my dear friends, why this nitrogen is relatively inactive? Its atom has a stable electronic configuration, it has low atomic radius, its electronegativity is fairly high, or dissociation energy of its molecule is fairly high. My dear students, when you can see the structure, you can see the structure of the molecule, and triple bond N molecule is present, and we can see this triple bond enthalpy is very high, or bond dissociation energy is very high due to this smaller molecule of nitrogen. So, this N2 is always formed while P2 is not formed. So, my dear students, you can go to the answer D, dissociation energy of its molecule is fairly high. Now, my dear students, we can go to the question number 16. Pure nitrogen is prepared in the laboratory by heating mixture. Here, if you know the reaction, then you can do easily this question. My dear students, here answer is D. Why? Because here when this NH4Cl reacts with NaNO2, NH4Cl reacts with this NaNO2, then you can get this NaCl, here this NaCl, and here plus twice H2O, all the oxygen atom are removed in the form of water, and 1 nitrogen and 2 nitrogen are present. That is why this N2 molecules evolved. Here, my dear students, I give you small trick to get this nitrogen you get or NO2 is get. Here, when we give this second reaction, in this second reaction, when you can NH4NO3 is heated, all the hydrogen atoms are removed as a water. Because here 4 hydrogen atoms are present, that's why it is removed by twice H2O, and plus remaining nitrogen is present here, that is N2, and 1 oxygen atom is remaining, that's why 1 oxygen is attached with this nitrogen. So you can get the nitrous oxide. Nitrous oxide is also a gas, and this is called laughing gas, nitrous oxide. So my dear students, we can here see the reactions, and by the reaction we can get this nitrogen pure condition. Now we can go to the question number 17. My dear students, which of the following statement is not correct for nitrogen? It is electronegativity is very high. D orbitals are available for bonding. It is a typical non-metal, or its molecular size is small. Now my dear students, we see the concept of this question. What is the concept of this question? Here, not correct. It means others are correct. Now, my dear students, we can see here its electronegativity is very high. Yes, you can see the fluorine, oxygen, and then nitrogen, third element, which is highly electronegative in all the elements of periodic table. So it is a correct, but you can see the non-correct answer. Number C, option C, it is a typical non-metal. Yes, it's a typical non-metal. Nitrogen is the form of N2. Its molecular size is small. Yes, its molecular size is small. D orbitals are available for bonding. No, not at all, my dear students. D orbitals are not present there. So it is not from NF3, NF5. This question is also asked in NEET 1990 exams. Now we can see here question number 18. Here, my dear students, in question number 18, urea reacts with water. Urea, what is the molecular formula of urea? So you can write here reaction. Urea means NH2, CO, this urea, my dear students, reacts with water to form A compound, which will decompose to form B compound. B compound, when pass through Cu plus 2 ions, it forms C compound, and color of C compound is deep blue color. What is the formula of C from the following? My dear students, here we can see the urea dissolved in water. When urea dissolved in water, it forms NH2 COO NH4 plus ion. Here H plus ions are from this water molecules and form NH4 plus ions. When this salt is removed, my dear students, then you can, this is decomposed into ammonia, NH3, and that is carbon dioxide. My dear students, when this ammonia is reacts with Cu plus 2 to form Cu NH3 whole 4 plus 2 ions, and this reaction is also you can get D block element. So my dear students, compound this C is the CuNH3 whole 4 plus 2. So my dear students, you can go the option B in this question. What is the formula of C from the following? This question is asked in NEET 2020.